Okay.
There
Weird.
you go.
Okay. Okay.
Okay. So yeah, pretty much we have to use the format that we were using for last assignment, the template from Excel.
Okay. 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 So do you have the Excel files for the quiz up yet?
I do.
Yeah.
Okay. So question 3, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. So when a simple random sample was drawn from each population, when, I don't know how to say that, when X is normally distributed for each group, when the mean is greater than 0, or when the sample size must be the same for each group.
Okay, so it's definitely not the fourth one because we're looking at two different tests. So they will have different means.
I think the first one is 1.
It doesn't have to be because, for example, remember the comparing like men and women of minimum of wages at BYUI? It was part of the homework. It wasn't a simple random sample. Like they chose those two groups and they chose like the women and the men. So I don't think that has to because of the example of the homework and it specifically said that it wasn't a random sample. I don't think that one's it.
Well, actually it says must, so probably yeah, you're right.
Mm.
Okay.
For sure it's 2. Like the mean is normally distributed for each group. Because in the homework, when we have to do the chart, hypothesis test for 2 means independent samples, it says, well, I'm looking at the answer key. The distribution of sample means from each group is normal. And so that's definitely it. And the mean is greater than 0, I would imagine, but I don't know what you guys think. I don't know. Like that one I'm not 100% sure.
So I did find it in the reading. It's the first one and the second one.
So it is the first one?
Uh-huh.
Really?
Yeah.
We can try.
It's in the reading it's above 3.1.2 and it's below what says step 4.
Oh yeah. Yeah. It's right there.
Okay.
There are two requirements.
Well, I don't get that very well, but
It doesn't super explain it either. um
cuz look, if you look at the answer key, question 6B, it says the sample size is large for each sample, so we can assume normality. Then the next line in, it was not a simple random sample. It was not a simple random sample, yet it was an independent, it was comparing two means with independent samples.
Yeah. I guess we can ask the TA or the teacher about it.
The good thing is that we have 2 tries, so
Mhm.
let's just put A and B. Should we put also C or no?
I don't think so for this one.
Okay.
Yeah, I guess first and second one. If we are wrong, we have like many tries right now because we are 3.
Okay. Let's do it. The test statistic for a hypothesis test comparing two means with independent samples is a
T.
Well,
t-square. Two samples are independent if
Okay.
it's B. Knowing which samples will be in group 1 tells you nothing about which samples will be in group 2. Do you all agree?
Yeah, that sounds right.
okay.
We'll need the dentist. One. Okay. Okay. So it says this data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let mean 1 be the mean bill at the Idaho Falls office and the mean 2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we will have the null hypothesis and an alternative hypothesis. Use the level of significance.
So for this one, we have to use, I think, the 2 sample t-test, right?
Yeah.
Yeah.
Okay.
We have a document that already has those formulas established, right?
Mm-hmm.
Where is that document again?
That's a good question. It was in the beginning of the semester, like
Okay.
syllabus, I think.
Yeah. I think I know where I can find it.
Okay, so this is confidence level.
Okay. I have it.
Okay, so for number 6, I have 37.996.
Degrees of freedom. Wait, for number 6, it's just n minus 1. So it's 20. Number 6 is 20, right?
No, it's 37.996 for me.
For number 6?
Yeah.
So is there yeah, is there a
So it should be a
or can
DF.
just use a function on Excel that can find it,
Okay.
Do
if that makes sense?
you want me to send that by email to you guys?
Well, I already have the document.
Okay.
So,
Andrea, where did you find it?
well, I had saved it in a folder.
Okay.
But I could email it to you really quick.
Okay. I probably have it somewhere. I'm just not sure what to look for.
Okay, I just sent it to you.
Okay.
And it's I sent you the folder.
Uh-huh.
You have to open the folder and it's the last document.
Okay.
And then in the document, the Excel,
Okay.
press on the third sheet where at the bottom it says to sample test, just press on that one. But Ricardo, don't you have to compute like the mean, the standard deviation, the sample, like don't you have to do the summary statistics, like write it down before you could get the degrees of freedom?
Actually, no. All you need right now is a confidence level that it says it's going to be 0.90 because it says 0.10. And yeah, pretty much what you have to do is just copy and paste all the numbers, and then you will have the DF right there. That's what I'm always doing. So I don't know.
Okay, I want to make sure that I'm understanding, so I'm gonna just re-say what you said, okay?
Do you want me to share my screen?
Yeah, that would help.
Okay, let me see. Screen share. Okay, I want to share everything. Okay, start screen share. Okay, can you guys see my screen?
We could see your screen with like 3 different things on it. Yeah.
Okay,
No.
so here is where we have all the information.
Mhm.
So pretty much you have to copy that, and then you have to paste here, and then you will have all the results here in the bottom.
Oh,
Okay.
Simple like that.
Ricardo, that's so easy.
Yeah, that's why these quizzes are super simple right now.
Okay. Okay. So what if, okay, so on mine, I just have one variable. So would that mean, this is probably a dumb question, but just do it one at a time.
You should have two because you have Idaho. Let's see.
For on the
You have,
quantitative inference procedures, because on your screen, just a second.
because you have to be in the two sample t-test you see here in the bottom.
Okay, maybe, do I just have
Because
one?
there are three different ones. One sample t-test,
I have the
a
one.
paired,
That's,
and the two sample t-test.
that is why I just have the one.
Ricardo, can you do me a favor? Can
Yeah,
you send me the file that you're using, like the same file that I sent to Kelsey? Can you send it to me?
yeah, sure.
Kelsey, the file that I gave you, is it working for you?
Well, I saw the ones that you sent me and I knew that I had saved them, so I opened them up in
Okay.
mine. And so I'm trying to see if I have, that's not the right one. The
Okay,
one,
how can I attach here? Let's see. Oh, here.
oh, I understand. Okay, I
Okay.
know where that.
This is the one that we're using. Let's see if I can choose. Okay, golden 3. Okay, I. Okay.
Okay. I'm gonna
Did you
see.
guys receive my email?
I found it. I did find the.
No.
I did get your email, but I found it in mine. Thank you.
No, I didn't. That's weird. Can you resend it?
Yep.
I'm not sure how many I have.
Let's see.
Okay. Whoops. So, is it 37.996? Is that what you
Yeah.
have? Okay. Perfect.
Okay, Andrea, check your inbox.
Hey, got it this time.
Perfect.
Perfect.
So yeah, this is pretty much what we have to use for the quizzes. And yeah, you don't have to worry about formulas right now because we have this, simple.
Yeah.
So you see if we modify, okay, so this is another thing.
Mhm.
We have to, in order to get the p-value, we have to modify here in the type of test. So are we agreed that the confidence level is going to be 0.90? Because it says that the level of significance is 0.10.
Okay.
Mhm.
Guys,
Okay.
real
Yeah.
quick, I was trying to open it. Can we just go like 10 seconds? Number 6 is 36 what?
Oh, 37?
37?
Oh, it's here in my screen if you can see.
Okay. 37.996. And then number 7, can you scroll down, please? Is 206. 206. 1, 6, 3, 7. And then number 8.
Okay, so for the other ones, we have to make sure that we have the right information here on the top. Like confidence level, type of test, assume. I think we should leave that on no. But are we agreed that it's 90, 0.90?
0.9. Yeah.
Okay, so is it going to be greater than, less than, or not equal to, according to the information?
The in the top it says so mean 1. So the Idaho Falls mean would be less than the one in Rexburg if for the alternative hypothesis.
Mm-hmm. And I don't know about this one. Assume equal variances. I'm not sure about that. I think we just need to leave that in no.
Okay.
Okay, so standard deviation is going to be the same. Test statistic is going to be minus 0.434. Can you read that, Andrea?
I can't yet because I was I've been trying to download the documents that you gave me, and I'm still trying to. My computer's being slow, so I'm a little bit behind you guys.
That's alright.
But I'm getting there. Cut. Actually, delete. Okay, guys, this is a really stupid question, but I feel stupid, though I need your help. So I'm trying to substitute the variables that we want from the dentist office into the charts of variable 1 and variable 2. However, there's already some numbers there, and I'm trying to delete them, but every time I delete them so I could put the other ones, things happen into the document, and so everything just gets screwed around. So how do you take out those numbers so that you could add the other ones?
Yes. Oh, it depends. Just copy and paste like that.
But then it's gonna... Okay. I could do this. I could do this. I could do this.
Okay, let's say that I'm missing all
Okay,
these
yeah.
numbers.
Okay, I did it. I did it. Okay, it wasn't that hard. Sounds good. So, now... What was your question, Ricardo?
No, I don't have questions.
But you were waiting for me? You asked
No,
me?
no. Oh, I was saying if you're fine with the numbers that we have.
Oh! I trust you guys, but I can't say that I got the same numbers because I'm really behind. So yeah, let's just say yes for the sake of time, okay?
Yeah, then we can just, well, if we are wrong, we have another try,
Yeah, sounds great. So what was it for the test statistic?
It's going to be minus 0.434.
Minus 0.034. Okay.
4.
Yeah.
434?
Yeah.
So negative 0.034.
Yeah.
Okay. What is the p-value?
It's going to be 0.333.
33. Wait. I got 667.
Yeah, and the reason is probably because you didn't change here in the type of test. You see here, my screen?
Wait.
We were saying that was less than, right?
Oh, okay.
So if you modify here to greater than, less than, or not equal to, your numbers are going to change. Pretty much are going to change in the p-value. So, yeah. And confidence interval probably.
So what are you putting?
So according to the information that we have, we are saying that the type of test is going to be less than.
Okay. Yep, then I get 333.
Yeah. So if you change that, and if you have a 0.90 in confidence level, you should have a 0.333.
Yeah. Yep. I've got it.
Yep. Okay. I have that too. I'm now on schedule. What is the correct decision based on this evidence?
I think it's fail, right? Because p-value is greater than.
Oh.
Suppose that you...
If the p-value is low, less than 0.05, we reject the null hypothesis.
If I'm not wrong, yes.
Yeah, so because it's higher, then we fail to reject. Yeah.
Yeah.
Okay.
Okay. Suppose instead that you used the alternative hypothesis. Mu1 is not equal to mu2. What is the correct decision based on this evidence?
Mm-hmm. Okay, so pretty much what we have to do is change here at not equal to, right?
Yeah.
Let's see how it changes.
The p-value is greater,
Greater, yeah.
but it's still...
The means are still different. Would it be the first one?
We can try that one.
Okay.
Okay, so for 12, we have to open a new one. Freshman dinner. Okay. Okay.
Okay. What would be the appropriate alternative hypothesis?
Hmm.
Hmm.
Not
that
equal?
mu is not equal to mu2. Yep.
Yeah.
Yeah.
Okay, so it says this case is going to be 0.95, not equal to t-test going to be 0.845. So do we agree that it's going to be 0.95 for the confidence level?
I just have a question.
Mhm.
Because the formula here is mu, like mean 1 is equal to mean 2, like that's the null hypothesis. In the chart, there is no equal, it's just not equal, less, or greater. What are you putting for type of test?
I think not equal to.
Okay,
I think.
sounds good. And so once you put not equal to, and like you put the numbers in the variable areas, what's your confidence level?
0.95.
No, okay. Your confidence level is going to be 0.95 because if we go to the information in the level of significance says that is 0.05. So I think I have a chart so I can show you what I'm talking about. Okay, you see here in my screen? So when we have 90%, it's going to be, well, 0.90. When we have 0.05 is 95, 0.01 is 99.
Yep. But guys, even after I put 0.95 not equal to, Oh, where it says assume equal variances, did you put yes?
No.
Okay.
Why?
No. Just wondering because my confidence level is, you know what? Just don't worry about it. Yeah, it's what did you guys say? It was 0.9.
Your confidence level, you have to do it manually.
No,
So yes.
in the two sample t-test, there's a chart for the confidence level.
Uh-huh.
Okay. No, yeah. I mean no. It's been a long day. Okay, so
Okay.
test statistic, what did you guys get? Because I'm getting,
All
yeah.
0.080 845.
Yeah, that's what I got.
What I think is happening to me is that I need to check the variables because I got negative 0.161, and I know it's
You,
wrong.
sh-
So I just have
you
to
sh-
go and check these things because, yeah.
Probably because you forgot to delete. Because now we have like 12 in variable one and 10 on the other one. So probably you have the one from the last question.
Oh, maybe.
So you have to delete everything there.
Okay. So it's 0.845.
4-5. Uh-huh.
Yes.
Okay, 845. 0.845. Um,
And then for the p-value, did you get 0.411?
Yes.
Okay. And do we reject or fail to reject?
Fail to reject?
I think it's reject because it's less. Oh no, zero point
It
0.0. Yeah, sorry, fail.
Because it's more.
Yeah. Okay, this question is the one that we were asking last week.
Mm-hmm.
So, okay, so for this case, the margin of error is going to be, I think what is that?
Oh, I, it's a 2.5. So here's like imagine a graph, and then the bell curve, like the place where you want to be is in the 45%, but then there's the tail, like where the p-value is on each side. So if you divide 5 divided by 2, so it could be on the tail, it's 2.5. I'm pretty sure.
Okay, so last week, well, I was like crazy trying to find the answer. So I know that in order to get this, you have to subtract the mean minus confidence. Well, I don't know which one is in this case. I have to go back because there's a formula, but it's not going to work. Okay, let's skip 16 and let's get 17. That is going to be the lower minus 2.214, and then the other one is going to be 5.147 and 16. I can't remember. Check. Oh, I got it. Okay, let me see. Let me see. Pieces. Last week was 12. Mm, 12 homework quiz. Okay, no. It wasn't homework, yeah, submissions. Okay. Where is it at? Let me see. Margin of error. Okay, he's here. Okay, let's see. Okay, 1 second. Okay. 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 Let's do the math. Yeah, I think in this case I got a result doing the mean minus the lower one, 9.591. Let's see. Okay, let me 728. Yeah, okay, so in this case, what's going to be the mean? Uh-oh, we don't have a difference. Okay, let's see if I can try like this. 17. Oh, yeah. 17.67. 15. Okay. Okay, so that's my difference. Let's see. 9.467. Okay. Then what's the difference? Let's see, let's try this. 455 minus 581. Okay, no. What? Oh no. Hmm.
Oh, okay. So
Okay.
the way that you establish lower and upper is lower is just subtracting the mean.
I'm doing like the difference of the mean that is going to be 1.467 minus the lower. So let's make a formula. It's like this. Minus.
Yeah. So,
Yeah, I think it's 3.681. We can try.
so what I looked online is that how to get the lower mean is to simply subtract
Well,
the lower bound is subtract
the
like what was that?
the lower is here. It's in the chart. Watch here in confidence interval. Can you see my screen?
Yeah.
So the lower is going to be here in the left,
Mhm.
and the other one is going to be here in the right.
Okay.
So that's why you have to put in 17 and 18.
But then what were you doing like a little
Okay, I'm trying to get the number 16 by doing the difference of the mean, which is a 1.467, and then I'm just subtracting that,
Oh,
the
okay.
lower, in order to get the 95% confidence interval.
Okay. I apologize. I thought you were focusing on number 17.
No, yeah, those are here in the chart.
Okay.
But I'm not sure if 16 is going to be right. We can try.
You can try it.
Okay.
Do you want me to submit just to see?
Okay.
Wait, what was 18 again?
5.147.
Okay.
Okay, I will submit just in case. Okay, we have 3 right, 4 right, 5 is good, 6 is good, 7 is good, 8, 9, 10 is good. Okay, 11, we have to fix 11. 12 is good. 13 is not right. What the heck is wrong? That's weird. Okay, 14 is good, 15 is good, 16 is good, so yeah, I did right in 16. 17 is good, what? And 18 is not good. That's weird.
So 13 isn't right.
I have, yeah, we need to fix 13. Okay, let me write it here. So 11, 13,
11, 13,
and 18.
18. Okay.
Okay,
Well,
Ricardo, can you tell me what you got for 16 again?
Yeah, it's going to be 3.681.
Okay. Thank you.
so 11.
Oh, sorry, and 17 is not right. Okay, so I probably know why we're not getting this right. So 17 and 18 are not right. I say 17 is 3. That's weird.
I think I know how to do 16 and 17.
No, 16 is right. 17 and 18.
I mean, 17 and 18. What I've been reading is to get the lower bound, you just subtract the two means, and then to get the upper bound, you just add the two means.
I had a formula, but we're supposed to have to get everything just using the chart. Well, if we don't want to mess up in the homework quiz. So probably there's something that we're doing wrong here. Okay, so probably it's not equal to, but that's weird because the p-value is going to be, oh, what the heck? Oh no, what is that? Okay, let's see. What if I change this to greater, less, not equal to? What if I put yes? Okay, so probably we have to switch assume equal variances to yes. But let's see, low, okay. No, because my test statistics is going to change. What?
Is this number 13 that you're working on?
Oh, that's why, yeah, because my test statistic is wrong. Okay, so yeah, so I think the problem is here that we should use yes in assume equal variances.
For number
Yeah,
13?
yeah, we need to change that in the chart. So let's see here. Let me see if I get the same p-value. What? Because it says that we have the right p-value, so let me
So why
try.
keep different then?
Yeah, it's a different p-value. So that would
Yeah, so yeah, it has to be no. Hmm. Confidence level is 95. Let's see. $8.45. What? That's weird because I'm getting 16 right, so how come?
Hello.
Hey guys, can we do number 11 just as like our minds process what number 17 and 18 could be? Because I did a different way, number 17 and 18, but I want to get a different answer for 11 and 13, so I could submit it and I could see if the way that I did it was right.
Okay, sounds good. So 11. So do we agree that it's sufficient or insufficient?
Okay. I can put the other variables in.
Okay, I'm
Or
gonna put,
Let's
I think it's sufficient. Like we have everything.
so let's try number 3.
Yeah, that's what I'm gonna do. Okay. So we already did 1 and 3, and then
13.
number 13.
Okay, there is another way to find the test statistic. So
Yeah, I have it here.
yeah.
Uh-huh. It's a long formula, so it's probably gonna take me like 5 minutes to do, but I could do it.
I think I have everything. See. Okay, I need.
So Andrea, did you submit it?
No, not yet. I'm gonna get number 13,
Okay.
and then I'll submit it, just so we
Okay.
have more tries.
Hmm. I need n for the formula. So what is n in this case? We have 12 and 10.
I think 9. Because I have that big black bag, and I think that's downstairs in my room.
Hmm.
Maybe. If not, then I'm not sure where it's at. But my mom has some in her bathroom.
I think 17 is just positive. Hmm. Fourteen. 15, 6 plus 6, 7. And I think 18 is going to be 5.148. Hmm.
Hey guys, I'm still figuring out number 13, but I'm close. Like,
Hey, did you check that in? Okay, so, oh no, 13. Okay, we have additional information between 15 and 16. Hmm. You know what?
it's taking a little bit longer than expected, so if you guys want, we could just
To be
figure it
honest,
out on our own.
to be honest, I think 13 is wrong, and you know why? Because if you go, well, if you check my score, it says that I have 16 of 19, and we have, yes, I think 18 questions.
It just
Well,
some questions have more points than others.
Oh, this. Oh, okay, that's why. But it's impossible because if we change something in the chart, we are going to have a different p-value.
Yeah. I don't get why that one would be wrong.
So what did you get for 17 and 18?
You're talking to me, right?
Yeah, Andrea.
Okay, so I got 1.467.
Okay, so 1.467 is going to be the difference between variable 1 and variable 2.
They're different numbers, okay? Just so you know for this. I'm talking to, sorry, my husband came home and he's very, very smart. So he's right now looking at what we're doing and he might help us a lot. So, anyway, these are the numbers. Okay. All right. So, I got 1.467 for 17 and 31.867 for 18.
Okay.
31.867. So what I'm going to do is we're going to try to figure out number 13 and then I could submit it right now, like in a few minutes after I'm done with 13. And if they're right, I'll let you guys know so you could submit it too.
Okay.
Okay, so in like less than an hour, you'll hear from me. Probably in less than 30 minutes. Hopefully in less than 10 minutes.
Okay.
But are you guys really going to email back?
Yeah, promise.
Okay.
Okay.
And also, if you can make sure that we have 11, I think it's 11, right? The one that we're missing, that we have wrong? Yeah, 11.
Okay. Sounds good.
Yeah. Let us know about 11, just in case.
Okie doke. Will do.
Okay.
All right, guys. Thanks for your help today.
Yep, thank you.
Yeah, bye.
Okay. Yeah, bye-bye.